Hey, physics friends, and welcome to lesson 3.3, part 2, which I've called Changing Between Position, Velocity, and Acceleration versus Time Graphs. The stuff that we're going to go through today is the most conceptually challenging. It's one of the top 3 for sure of the entire first semester. So if you've got your phone or you're doing something else right now, please try to set this aside for this period to really press in to pay attention to this, because this is pretty challenging, and I want to make sure that you're getting the best that you can when you're doing this. So what we're going to be doing today, in a nutshell, you're going to be given like a position versus time graph, and then you're going to take that position versus time graph and create the velocity and create the acceleration versus time. Or maybe you're given the velocity versus time graph, and then I say create the position and create the acceleration versus time graph. Now, you all have pretty good groundings on what these graphs mean. Like up to this point, if I told you to make this graph, you might be pretty good at doing it actually. Standing still, moving at 5 meters per second, moving at negative 10 meters per second, then standing still, speeding up, constant speed, slowing down, standing still, speeding up, moving in the negative direction. So you kind of have a good basis of what's happening, but today we're going to put numbers to this and create these other two graphs. So at the top of your notes, I kind of have some steps on what to do. So we're going to follow these steps, and I call it going down, meaning you're at the position versus time. Make the graph below it. So go from this graph to that graph. You're going down in this order. And these graphs will always be position, velocity, acceleration. Everybody I've ever seen all along the way, they have them in that order. They don't mix them up. Going up, meaning that if you're starting from a lower one, like you have the velocity versus time, going up and creating the position versus time. So let's get started. Step 1, it says find the slope at every point. So here's what I mean by that. When I'm, first of all, when I'm going down these graphs, each of these points has their own unique slope. And for instance, all of these points right here, they all have the same slope. All of these have a slope equal to 0. All of these points have the same slope. All of these have a slope of up 10 over 1, rise over run. So these all have a slope equal to positive 10. All of these points have the same slope. So they're going to have a slope equal to, looks like going up 20 over 1, positive 20. Again, these have a slope of 0. These all have the same slope. I mean, you're going to see right here. Here's the crazy part where they have different slopes. So up to this point, these are all having the same slope everywhere on this line. So this is going down 40 over 1. So this has a slope of negative 40. This has a slope of 0. Now, I'm going to skip over this section for right now, and I'm just going to do this end part, because that is from 7 to 9 seconds is the only tricky part about this graph. So this has a slope of up 30 over 1. So this has a slope of positive 30. All right. These points right here, this section, when it curves, that's tricky. The slope right here is different than the slope right here, and that's different than the slope right there. The slopes at each of these points all are different amounts. The slope right here is equal to 0. The slope at the end is equal to 30 because it lines up with that line right there. My guess, it doesn't have to be now. It takes calculus to really figure this out, and this is called the derivative. But my guess is the slope right here is probably 15. It doesn't have to be, but in reality, it doesn't matter. Like, we don't care. All we really care about is the middle one and the end one. In high school, this stuff goes really deep, kids, and Isaac Newton invented calculus specifically for what we're doing right now. So whenever you come to a curved section, all you need is the slope at the beginning and the slope at the end. And maybe you can be clever and, oh, look that's the same slope as what this was. Maybe you have to draw a tangent line and take your slope. But whatever you do, you have to find the slope at the end and go from there. Now, next step on this whole journey, if you go back to your notes, after we found the slope at every point, plot the points. So here's what I mean by that. So go back. Plot these points. Whenever the slope is what the velocity is. You all know that you're standing still here, so that means that your velocity is 0. That's what my slope was for all these. Here, I'm going at 10 meters per second. So, you notice that I'm going to go off the graph. My graph only goes up to 10, so I'm just going to adjust my scale right here. I'm going to make this 20, and I'm going to make this 40. You can totally do that. Just adjust your scale if you know it's going to go off. So now, the velocity here is positive 10. So I go up to 10, and I'm moving at a constant speed of positive 10. Now my velocity is positive 20. The slope is what the velocity is. My slope everywhere is 20, so my velocity everywhere is 20. My velocity is 0 through that whole interval. My velocity is negative 40. My velocity is 0. See, I'm pulling these numbers. And now my velocity changes. My velocity here is 0, and my velocity at the end is 30. Here's an example where you're increasing your speed. And now my velocity stays constant. Everywhere here, the slope is 30, so I stay at 30. Hopefully that makes a little sense to you. We'll do another example if it doesn't. When you go from this graph down to your acceleration versus time graph, you're going to take the slopes as well. And this gets a lot easier because everywhere, let me go back to my red. Everywhere here, the slope is equal to 0. Everywhere here, the slope is equal to 0. Check out what this means. I'm standing still. There's no acceleration. I'm going at a constant speed. There's no acceleration. I'm also going at a constant speed. There's no acceleration. Constant speed, no acceleration. Standing still. Constant speed, no acceleration. Constant speed, no acceleration. Here I actually have acceleration. My slope through this section right here, I go up 30 over 2. The slope is a positive 15 meters per second per second. Up 30 over 2 seconds. So my slope is positive 15. And at the end, my slope is 0. Now, unfortunately, I can't move. If I scroll down, you're going to see that all this stays still. So bear with me. Pretend. I'll do a better job next time. Pretend this is 0. So I'm going to have a line at 0 the whole way down. And then it jumps up to positive 15. So if you want to adjust your axes, or I can just go off like that. So there is your graph for your acceleration. Cool? Let's do another one. Here's your next graph. Again, plot the slopes. In the middle here, this is where it gets a little bit crazy. My slope here is 0. And now, here's kind of a tangent line at the end. So right here, I'm just going to estimate my slope. It goes down 20 over 0.2. Again, there's a little bit of guesstimation here. So my slope is down 20 over 0.2. So that's like 200 over 2, which is negative 100. So that slope right here is negative 100. And then the slope right here equals 0. So this is the only sketchy piece to this one. And let me show you how I deal with it. Again, when you have a curved part, you only have to find the slope at the beginning and the slope at the end. And here's an example where I drew a tangent line and I estimated the slope of that. And I estimated it to be negative 100. You may get something different. There's always a little bit of leeway when it comes to doing something like this. Okay, so my slope is 0. I got to adjust my scale. I'm going to make this negative 100, positive 100. So that's going to make this 50 and this negative 50. So negative 20, 0, positive 30, 0, right? And then negative 100. So my velocity here is 0, and then I go down to negative 100. I'm increasing my speed in the negative direction. And now I'm decreasing my speed, but I'm still moving in the negative direction. I go from negative 100, my slope right here is negative 100, and then my slope right here is 0, so I have to end up at 0. I'm stopping. And now I have a slope of 40, and then negative 20. Like that. Now to go from this graph to this graph, I'm just going to rinse and repeat. I'm going to find the slopes at all of these pieces. These slopes are all 0. These slopes are all 0. So it makes this part of my graph, I'm not accelerating. There's no acceleration here. I am accelerating and then I'm decelerating. So I have a slope here. I go down 100 over 1. And here I go up 100 over 1. So the slope, I'm going to, again, make this 100, make this negative 100. So negative 100, positive 100, like that. In high school, this graph will never curve. In high school, you will only have horizontal lines or diagonal lines. You're never going to have a curve in the velocity versus time graph. In high school, you're never going to have a diagonal lines. In high school. I want to keep this stuff pretty straightforward, not too complicated, so you can start to figure out, how do I go from this graph to this graph? I don't want to make it too hard, but that's how you go down the graphs, how you go from position down to velocity. Next, let's take a look at how we're going to go from velocity. So here's our third example. How do you go from a velocity versus time graph? How would you go to a position? How do you go the opposite way? And let me show you. Step number 1. Draw a horizontal line at 0. Here's what I mean by that. So what I'm going to do, I'm going to draw a horizontal line at 0. That horizontal line represents when you're stopping. I'm not going to scroll back up. I have your rules right here. Step number 2 says, find the area between the line and the curve. Here's what we're doing with this. You all know what's happening right here, don't you? You're stopped. So if we don't know where you start, but let's say you started at 0. You don't move. And you all know from your prior experience that this means you're moving at 5 meters per second for 1 second. So if you go 5 meters per second for 1 second, how far did you move? Yeah, 5 meters. That's exactly right. What I'm doing is I'm finding this area. This is up 5, and this is 1 second because that's from 1 to 2. So this has an area of positive 5. That area represents how far I move. So here I've got an area. And notice I'm changing to blue. This is a negative displacement. I'm moving at negative 10 meters per second for 2 seconds. So if I'm going at negative 10 meters per second for 2 seconds, I ended up moving negative 20 meters. That's my displacement. Here, my area is 0. I'm stopped. Here's where it gets kind of crazy. Again, I'm switching back to red because I have a positive area, and this is a triangle. I'm speeding up. So finding the area of a triangle is 1/2 base times height. So the base is 1. The height is 5. So 1/2, 1 times 5 is 2.5. Well, that could have been nicer, but that's not a big deal. This area is 5. And then this area is the same thing. I'm slowing down, but it's still going to be another 2.5. And it's not going to be a negative area because the only way you get a negative area is if you're below this. And it's really important to see how I use blue and red accordingly. My red tells me that I'm moving in a positive direction. And if you've got red or blue, I want you to do this too. Positive. These are all positive displacements. And I go to blue when these are negative displacements. So this is a base of 1, a height of 10, half of that, negative 5. And then everywhere I don't move, I use black. So that is step number 2. Step 1, we drew the horizontal line. Step 2, find the areas. Step 3, put dots on the graph. The area is how much the graph changes. And this is a big difference. The area is how much my position changes. So if I'm at here, I change positive 5. Right? And then I change negative 20. So that I end up at here. I'm at negative 15. I don't go to negative 20. I change negative 20. That's the difference between slopes and my areas. Like you all know that if I went at 10 meters per second for 2 seconds, oops, that should be over here. I'm going to go 20 meters. Here I went that. So where I'm going with this is I'm going to connect these dots. But first, I'm going to put the dots in. So here I change 0. So I'm still at negative 15. Now I change 2.5. So I'm at like negative 12.5. Here I change another 5. So that's going to be negative 7.5. And then I change another 2.5, so I'm up here at negative 5. And then I change 0. Again, this is how much I change. And then I change another negative 5. So I end up at negative 10. So if I started at 0, and again, we don't know where you start. We're just going to assume you start at 0. Wherever you start this graph, you're going to end up 10 below, 10 in the negative. So if I started at 20, if I made my graph, I would end up here at 10. So the next part. Part 4, connect the dots. Connecting my dots. So here I'm standing still. That's a straight line. Here I'm speeding up. This is a positive slope, so you need to connect it with something we call concave up, or I say happy face. So I'm going to connect this with a happy face. See how like happy face is smiling? Constant velocity, so straight line. Sad face. It's going to sad. Curving down. And you can even write, if you're like, oh, I don't know if Mr. Hare is going to see that. Curve. And you can say concave up. And this will be, you could write curve if you want, and you would say concave down. Standing still, straight line. Here, negative. That's a sad face. Negative slope means we're connecting this with a sad face. How am I going to do that? Ooh. Oh, yeah. Oh, I don't go here. I go here. That's why I was confused. This isn't something I'm using. There. Sad face. So here we did. We went from velocity to position. Okay? Now, if you want to make this graph right here, you go back to the first set of rules where you're using the slope, right? I'm going to grab green because it's a color I haven't used. The slope here is 0. The slope here is 0. The slope here is 0. So we've got 0 slope. The slope here is 0. Now we've got slope. I'm going up 5 over 1, so I have a slope of positive 5. Slope of 0. Slope of negative 5. Slope of 0. Slope of negative 10. So this is what my acceleration versus time graph would look like. Let's do one more example. Last one. I'm just going to whip through it because I know this is taking a long time, and I'm really sorry because this is taking a long time. But I'm going to speed myself as I go through this. And there you have it, kind of in real time for Mr. Hare. I know this is a long one, and I don't know how well you did kind of hanging on, but stay with this. This is a challenging thing. Make sure that you run through your rules when you do this. We're going to sit on this for a few days, but stay with it. Stay positive. Get help. We'll see you later.